Apple Research just dropped a paper at the Worldwide Developers Conference that threw buckets of cold water on AI developers and their hype. What was it that Apple's researchers found out about large reasoning models? You're going to find out right now on Tech Talk. So Apple dropped a report this week on the current state of AI reasoning models that developed some pretty exciting headlines. Check out a few of them. This one's from Tom's Hardware. They said, Apple says generative AI cannot think like a human. Research paper pours cold water on reasoning models. From Mashable, the illusion of thinking. Apple Research finds AI models collapse and give up with hard puzzles. Lastly, from Forbes, intelligence illusion, what Apple's AI study reveals about reasoning. So this is really interesting. All these articles came out just on June 9th following Apple's bombshell research report. And what was it that Apple did here? Well, they set out to test 3 different large reasoning models. Now, just so you're aware, large reasoning models are the version of artificial intelligence that is closest to the goal of artificial general intelligence. The idea of a machine being able to think and reason and act independently more or less like a human. So the models they tested were OpenAI's DeepSeek R1, Anthropic's Claude 3.7 Sonnet Thinking, and OpenAI's O3 Mini. Now, with the first 2, DeepSeek and Claude, they compared both the large language model version of those AI, that's the version we have now like in ChatGPT that uses pattern matching, and they compared that to the same AI but the large reasoning models. So both Claude and DeepSeek have a large language model and a large reasoning model under the same umbrella, and the 2 were being compared. So at the end of the day, what does all that mean? That's a lot of verbiage. Well, let's talk about the difference between large language models and large reasoning models, because they're very, well, not very, very different, but there's a significant difference there that's important to understand. And we're going to go to the web for this because I can't explain it better than what others have already done. The website Geeks for Geeks says this about a large language model. It says it's a type of artificial intelligence algorithm that applies neural network techniques with lots of parameters to process and understand human languages or text using self-supervised learning techniques. Tasks like text generation, machine translation, summary writing, image generation from text, machine coding, chatbots, or conversational AI are applications of the large language model. So a large language model is just what it says. It's there to understand language. You can talk to it, it talks back, it can generate text, it can write code. And generally LLMs, large language models, they work by what's called pattern matching. So they recognize patterns and their response are based on what they know about the patterns of speech, the patterns of writing that are appropriate. Now that's different than a large reasoning model. Let's go to the Microsoft Community Hub to see what they have to say about what a large reasoning model is. They say reasoning models are a new category of specialized language models. They're designed to break down complex problems into smaller, manageable steps and solve them through explicit logical reasoning. This step is also called thinking. Unlike general-purpose LLMs, which might generate direct answers, reasoning models are specifically trained to show their work and follow a more structured thought process. So these large reasoning models, the whole purpose of them is to be a lot more like human thought, to be a lot more independent, not just a pattern matching engine. So reasoning models are what we have now that's closest to the goal of artificial general intelligence. And it's kind of the path that is assumed to be the route we'll take to get to general intelligence. That these reasoning models will be developed and improved until the point where we have artificial general intelligence. So when we look at Apple's research then that they did with these AI models, what was it that they were looking to uncover and to discover? Well, here are the questions that Apple said it wanted to be answered. I don't think I included all of them, but I included the ones that I thought were most important. First, they wanted to know, are these models, now these are the reasoning models, are they capable of generalizable reasoning? Or are they leveraging different forms of pattern matching? Now, pattern matching, of course, being a much more rudimentary version of artificial intelligence. The second question they had is, how does their performance scale with increasing problem complexity? Third question, how do they compare to their non-thinking standard large language model counterparts when provided the same inference token compute? Now, an inference token is just a unit of data processed by an algorithm. So what that question is saying is if you take a large language model, compare it to a large reasoning model, give it problems with roughly the same data, same complexity, etc., how do they compare to one another? That's what that question is saying. The last question that I thought was significant was, most importantly, what are the inherent limitations of current reasoning approaches, and what improvements might be necessary to advance toward more robust reasoning capabilities? So this is really a question that says, look, if we're going to get to AGI, if we're going to continue growing our reasoning models to get to the point where we have artificial general intelligence, what are the limitations we're experiencing now? How do we get over those limitations so that we can continue to progress? So interesting set of questions here. And what was the answers that Apple got to these questions? Well, let's take a look first at how they went about getting answers, because they're not the first to test artificial intelligence models. So what's different about the way Apple went about this than the way everybody else has? Well, it's pretty interesting because Apple said they felt there were deficiencies in the way artificial intelligence had been tested up till now. And the problem in their mind was largely that when AI is being tested, they're focusing largely on mathematical and coding benchmarks. And to their mind, that left gaps in understanding exactly how it is that these reasoning models go about thinking. And I find that use of the term in this report, thinking, interesting, because humans think. No one has ever said that computers think. Thinking is different. That's a very independent sort of learning and adaptive process that we know is part of what's inherent to artificial general intelligence. So anyway, because we were always focusing when testing AI on mathematical and coding benchmarks, they feel there's a gap in the way we understand thinking. This is what they had to say about that with their study. They said, in this work, we systematically investigate these gaps with the help of controllable puzzle environments that allow precise manipulation of compositional complexity while maintaining consistent logical structures. This setup enables the analysis of not only final answers, but also the internal reasoning traces, offering insights into how large reasoning models think. So what's that saying really? Well, they're saying what they did was they gave these LRMs puzzles to work on. And they're puzzles that you can increase the complexity, but even as the complexity increases, the logic behind solving the problem remains consistent. So let's take a look at the puzzles it gave them. I've just picked two. There were a total of 4 in the report, but the 2 I thought were the simplest to understand were the Tower of Hanoi and the checkers jumping problem. Now, if we look at the Tower of Hanoi, that's pretty simple. You've got discs of multiple or different sizes stacked up on one of 3 pegs. It's on the left-hand peg. And as you see there, the biggest disc is on the bottom, the smallest disc is on the top. And what the challenge is you can move one disc at a time, and you have to move all the discs from the far left peg to the far right peg. The key is you can never put a larger disc on top of a smaller one. Now, this isn't a particularly challenging puzzle, especially when you're only dealing with 3 discs. And actually what I did, I went on mathisfun.com, which is a great website for these kinds of little brain teasers, and actually did the Tower of Hanoi. They have the Tower of Hanoi there, and you're seeing it on this video is my doing the 3-disc Tower of Hanoi. As you can see, it doesn't take very long to figure out. It's a pretty straightforward puzzle. The key with the Tower of Hanoi puzzle, though, is that the complexity increases as you stack on more discs. You go from 3 discs to 4 discs to 5 discs to 6 discs to 10 discs to 20 discs. The logic behind how you solve the puzzle is the same, but the complexity increases. The other puzzle that they gave them, or one of the other puzzles, was the checkers jumping puzzle. And you can see that in this illustration here as well on the right. There's 2 blue checkers on the left, 2 red checkers on the right. You're allowed to move a checker to one empty space at a time, or to jump another checker one at a time. And the idea is to eventually get to the point where the colors have swapped in. So you start out with the blue on the left, red on right. It ends up with red on left, blue on right. And again, the logic is the same as complexity increases, and the complexity is just increased by adding more checkers. So these are the kinds of games, these are 2 of the 4 games that the computers were given. The others were very similar. They're basically grade school kid games. They're not, particularly hard challenges. They're not solving the mysteries of the universe here. Just to give you an idea of how I did play the Tower of Hanoi for 10 or 15 minutes. I was able to successfully complete 5 discs. That's just 10 or 15 minutes of trying. I've never done it before, so that's about how long it took me to figure that out. So keep that in mind as we go forward here. So looking at these tests that these Apple researchers gave these AI models, how did they fare? Well, let's take a look at their conclusions. I think there were 4 key conclusions that I kind of honed in on here. the first thing that Apple said in their report, conclusion number 1 that I picked out, was despite sophisticated self-reflection mechanisms, these models fail to develop generalizable reasoning capabilities beyond certain complexity thresholds. We identified 3 distinct reasoning regimes. Standard large language models, that's the models that we have now like ChatGPT, they outperform reasoning models at low complexity. The large reasoning models excel at moderate complexity, but both collapse at high complexity. And they define collapse as being a complete accuracy collapse. In other words, these models are no longer to get satisfactory and correct results. So the question you're probably asking is, at what point did these AI models suffer that accuracy collapse? Well, you're going to be surprised at how low those numbers are. So let's just look at Claude 3.7. The Claude 3.7 large language model had a sharp drop-off in accuracy after just 3 disks. 3! And complete failure to correctly solve the puzzle after 8 disks. The Claude 3.7 large reasoning model, so this is the more powerful, more AGI-like, more advanced model, had a sharp accuracy drop-off after just 5 disks, and virtual failure, so a low single-digit success rate after just 10 disks. And the success rate went to 0 at 15 disks. So just after 5 disks, you saw a huge drop-off in its accuracy. It dropped something like 40%, I don't know. But that's pretty surprising, because like I say, I got the 5 disks completed in like 15 minutes. It wasn't that hard, right? You'd think that something that's supposed to be artificial general intelligence and is being touted as being the, going to lead us to an era of abundance and all these wonderful things it's going to do, you'd think it'd be a little bit smarter than that by now. But that seems like a pretty low threshold at which these things started to fail. Now, keep that in mind, because the next point that in Apple's conclusions was interesting as well. So they said, particularly concerning is the counterintuitive reduction in reasoning effort as problems approach critical complexity, suggesting an inherent compute scaling limit in large reasoning models. Our detailed analysis of reasoning traces further exposed complexity-dependent reasoning patterns from inefficient overthinking on simpler problems to complete failure on complex ones. So there's really 2 things going on here. The first thing that they're saying is, look, we noticed that as the problems got more complex and the reasoning models got closer to failure and their inability to answer the questions, it's like they gave up. They were devoting less and less energy into trying to figure out the problem. So normally you would think that if it's struggling to figure the correct solution, it would be using more and more resources, but it wasn't. The resource use was dropping off and they were putting less effort into coming to the conclusion. And they literally said in the report, it's kind of like they were giving up. So it got hard, machine just gave up. So that's really interesting. And that has been, in the second point there, it's depending on complexity, they're seeing the repeated behaviors over and over. So when the complexity is high, they see that tendency to quit over and over. In low complexity, and this is something that all AI has had a problem with, I've read about it from other models as well. At low complexity, for some reason, artificial intelligence has a tendency to obsess over wrong answers. So it'll figure out a low complexity problem, it'll come to a solution, but it'll keep going back to analyze things it already knows it's wrong, and it'll keep trying to find a solution even though it's already got one. That has been a bit of an AI problem that they've been unable to kind of solve for. So that was an interesting finding, this tendency to obsess about incorrect answers and low complexity problems, and then just for the machine to quit on high complexity problems. So that was the second discovery that they found, these researchers at Apple, the second conclusion. Now the third conclusion they came to, they said these insights challenge prevailing assumptions about large reasoning model capabilities and suggest that current approaches may be encountering fundamental barriers to generalizable reasoning. So what does that mean? Well, when you think about generalizable reasoning, that is artificial general intelligence, the approach to general intelligence. And they're saying that these issues may be fundamental barriers that prevent them from getting there. So that's a pretty profound statement to say that, right now, this is a fundamental issue that's standing in the way that doesn't appear to be solvable. Conclusion number 4 they came to, they said, finally, we presented some surprising results on large reasoning models that lead to several open questions for future work. Most notably, we observed their limitations in performing exact computation. For example, and this blew my mind, For example, when we provided the solution algorithm for the Tower of Hanoi to the models, their performance on this puzzle did not improve. So that's pretty shocking. The reasoning model was given the answer, the algorithmic answer to solve the problem, and the performance didn't improve one bit. I don't even know how that can happen, but it's a pretty shocking result. I don't think anybody in the human realm, if you went to write, a college or high school exam and you were given all the exam answers in advance, I don't think any of us would, fail to improve our mark on the exam. And yet that seems to be exactly what happened with these reasoning models. They were given the answers and the results got no better. I think that's pretty shocking. And I think it's a shocking statement as to where we are in the line or timeline of developing artificial general intelligence. At the end of the day, it doesn't seem like we're that far along. So I guess that brings us to the next question is, what do we make of this Apple report? How are we to kind of internalize this and what use do we make of this information? Well, I think people looking at it are going to assume one of two things. Either going to assume the report is true, and I kind of do. I mean, Apple's been a reliable organization. I know they're a corporation, and all corporations you kind of have a little bit of mistrust for, but Apple's not the kind of people to throw out a report that's complete falsification, so I don't buy it. But if you were to play devil's advocate and say, well, what motivation do they have to be dishonest about this? It is true that Apple is way behind its competitors when it comes to developing artificial intelligence. They haven't put in as much energy or money to it. AI hasn't rolled out in their products as much as it has in others. But there's a flip side to that, right? So it could be that because they're behind, they're wanting to poke a stick into the spokes of their competitors. But it could also be maybe Apple knows something about the development of artificial intelligence, and particularly artificial general intelligence, that other companies either haven't cottoned on to or at least aren't accepting. Maybe these barriers to development that Apple is speaking of in the report, maybe they've kind of known all along that there was going to be some big hurdles and they just didn't want to rush into the space and devote a whole ton of resources to it. I could go either way on that. I'm not too sure what to believe there, but generally speaking, I'm inclined to believe that Apple, this is a legitimate research report from Apple. They've done their homework. They're not being, purposely misleading in the way they're presenting these results. So if the report is true, then, it could be that we're a lot further away from developing artificial general intelligence than we assumed. I think most of us assume because, there's so much hype in the space, right? I think most of us assume that, oh my goodness, we're right on the doorstep. I've heard people say everything from like 90 days away from AGI to 1 to 3 years to 5 years, and 5 years is usually the outside. That kind of has been the window, but it seems like there's barriers to this that we don't have solutions for. So goodness only knows, when AGI is going to be achievable, if it ever is. And that brings us to the question, why would these developers of AGI lie? Well, the simple answer is money. There's a lot of money in the artificial intelligence space from government grants, from investors, putting their cash in to develop these things, from rising stock prices, and nobody gets rich by saying, yeah, we're working on AGI, but our models are terrible and we're nowhere near it. People make money by hyping the results and making it seem like they've done more than they have. So I think that, the money that's involved in artificial intelligence right now is driving some of the hype around it. But it certainly seems like the folks at Apple aren't necessarily buying it, and they have some data to back up their point of view. However, I want to kind of strike a note of caution here because, if we accept this information from Apple, we may have a tendency to say, well, artificial general intelligence, then, it's not near being developed, so we don't have to worry. But remember, we still have the artificial intelligence we have today, which is the large language models that rely on pattern matching. And those are still very, very powerful. What ChatGPT and OpenAI and others have been able to do, it is pretty amazing. This is functionality, the ability to make videos and images and to write text and to respond to speech. We've never seen this before, and we've got capabilities today that 3 years ago even was almost unimaginable. So artificial intelligence is still a thing, and it's still having a huge impact on our society. Just in the last several months, Google, Microsoft, IBM, Procter & Gamble, they've all had massive layoffs that they basically accounted for as a result of AI implementation. Now, they said it was either wholly as a result of AI or partly as a result of AI. It doesn't really matter either way. We're talking about thousands upon thousands upon thousands of headcount reductions at just those companies. So the artificial intelligence we have now, even though it's the simpler, more dumbed down version, it's still having huge impacts on our society, and it's still something that we need to be aware of. So at the end of the day, we're going to have to wait and see how all this plays out. And if we're trying to read the tea leaves, it's important to remember that technology doesn't always advance in a linear fashion. It's not always a nice, even, straight line as we progress, and I think AGI is going to be one of those things. If I had to guess, I'd say probably one or two things is going to happen. Either there's going to be a breakthrough where suddenly we've overcome these barriers that Apple has identified and the growth or the progression to AGI just explodes. Or it could be that these barriers are largely unresolvable. And this is a point that I think gets overlooked a lot, is we sometimes assume that technological advancement is just a given, that whatever we think of we want to do or we want to develop, we can do it. There's no reason why we can't. That's sort of how people tend to think. But every now and then we come across a technological problem that we can't resolve. And for me in my lifetime, the big one has been nuclear fusion. Nuclear fusion was first touted as a source of cheap, reliable, clean energy way back in the 1940s. In the 1950s, they started trying to develop it aggressively, and for my entire life, I've been reading, scientific articles and news articles saying that a world of ultra-cheap, ultra-clean energy that's readily available and abundant is just around the corner because we're just on the cusp of solving nuclear fission. Well, today we're still throwing billions of dollars and tons of energy into it, and it's like 75 years later, and we're still working on it. And I'm not saying, we're never going to accomplish it, but 75 years is a very long time, and we still don't have a single source of energy coming from nuclear fission. And back in the 50s and 60s and 70s, it was just assumed that by now we'd have all the free energy we could handle. So sometimes technology isn't as easy as it seems, and sometimes it's not a given. Maybe that's going to happen with artificial general intelligence. Maybe the hype and our enthusiasm for it went ahead of the practical limitations and challenges that would come from trying to develop it. Personally, if those challenges and those roadblocks slow things down, I'm okay with it. I would like to see things kind of slow down in this department anyway. In any event, at the end of the day, only time will tell. Now, I'm going to put the link to Apple's study down below if you want to read it. It's really kind of interesting reading, although it's pretty dry. It's only 30 pages long, though, so it's not a huge book you got to go through. It's kind of interesting to at least breeze through and see what they had to say. If you enjoyed this video, don't forget to like and subscribe. That helps me out a ton. I'll look forward to seeing you on the next video.